Hello there, welcome back to the part 2 of Fertilization and Anatomy on Zoom. Enjoy and don't forget to like, subscribe, comment and share. That's what motivates me to do a lot of these videos.
Okay, and then only 300 to 500 reaches the ampulla. So most of them die on the way. It's okay. Most of them are not able to reach. How can we say that only 1% of the sperm deposited in the vagina enters the cervix? So out of the 200 to 300 million sperms deposited in the vagina, only 300 to 500 which is the ampulla. Okay, and then out of the 300 to 500, only one of them will fertilize the secondary oocyte. So the fastest one is able to reach the secondary oocyte first will be the one to fertilize the secondary oocyte. So that's 200 to 300 million sperms deposited by your father. You were the fastest one among that 200 to 300 of them. Do you understand?
Yeah.
So your father deposited 200 to 300 million sperms in the vagina of your mom. And then out of that, only 300 to 500 reached the ampulla, okay, of your mother's uterine tube. And out of them, you were the fastest, okay? You were the one who so let's say you were the using both among your father 200. So don't let anyone look down on you. Out of your father's 200 million to 300 million spermatozoa, you were the fastest among them. You're okay. So everything is possible. If you were able to reach the oocyte first, so everything is possible. So don't let anyone look down on you.
Oh wow.
Okay.
Yeah.
All right. So yeah, I think only one of them will eventually fertilize the secondary oocyte. Then what happens to the remaining spermatozoa? Okay. So they function or they aid the fertilizing sperm in penetrating the barriers. Okay, so they will act like spectators, sharing the using both among the sperms. Is okay. Giving them fun or giving the one that will fertilize the egg or the secondary oocyte fun. And then some will also help it to break the barriers. So some will help it to break the coronal radiator and then also the zona pellucida. Okay. And then of course earlier we said that only capacitated sperms will be able to pass through the coronal radiator and then the zona pellucida. Any questions?
Sir. Hello. What kind of microscope did they use to find out all these things?
So we have electronic microscope. Not the normal. You have electron microscope, not the normal microscope that we use.
But the electron microscope, the cell has to be dead, right?
This is a good question. Okay, so when my other 200 million siblings go to heaven. That is interesting. What do you think?
I think
These are the questions someone is asking. Yeah, well, my other 200 million siblings go to heaven.
yeah.
One you ask you, does it mean that you were the most hyperactivated? Of course,
Yeah, make you nice.
Hey, ladies, for making noise, please keep quiet or mute yourself.
Please, what time will we close?
right. So the thing that all capacitated and passes freely toward the source of the corona radiator. Right. So phase 2 has to deal with what?
Sir.
Yes.
Hello, sir.
But I didn't hear what you said.
Please, I wanted to ask, how does the spermatozoa aid in the penetration of the single sperm? I wanted to ask, how does the other spermatozoa aid in the penetration by just a single sperm? How does it aid?
Aid in the penetration of the single sperm. So what you are saying is that they help in breaking the barriers. Okay, so they help in breaking or paving way through the barriers. So first of all, they help in penetrating through the coronal radiator and then the zona pellucida. Don't worry, we are going to take them one after the other. Okay, so the first phase of it, we can see the sperm to penetrate through the cells surrounding the coronal radiator. Okay. So that's the first phase. Okay, you should be able to penetrate, okay, the coronal radiator, the cells of the coronal radiator. Now I'm sure Mr. Kuti taught you what the zona pellucida is. True or false? Mr. Kuti taught you zona pellucida, right? Hello. So the zona pellucida is actually what a glycoprotein, okay, covering the primary side. It's actually made up of 4 glycoproteins. So we have zona pellucida 1, zona pellucida 2, 3, and then 4. The function of zona pellucida 4 is unknown. Okay. The function of zona pellucida 3, okay, is to permit the binding of the spermatozoa and then facilitate what? Autosomal reaction. Okay, so zona pellucida 3 permits the binding of the spermatozoa and then facilitate autosomal reaction. Now that of zona pellucida 2, okay, they serve as what? A secondary binding site. Okay, so zona pellucida 2 is also responsible for binding spermatozoa. They act as what? A secondary spermatozoa binding protein, just like the zona pellucida 3. But what happens is that after fertilization, the fertilized oocyte, which is now called ovum, secretes an enzyme known as what? Ovastatin. Now, this ovastatin degrades the zona pellucida 2, which is a secondary binding, or which is a secondary spermatozoa. Degrading it prevents the binding of what? Additional spermatozoa to the zona pellucida. Okay. So if this ovastatin wasn't produced, that means that sperm, or we can have multiple sperms from fertilizing the single oocyte. But ovastatin shows that the zona pellucida 2, which is a secondary spermatozoa binding receptor, is what? Degraded. How do you understand? And then zona pellucida 1, serve as what? A cross link, okay, between zona pellucida 2 and then 3, and then also prevent multiple sperms from what? Binding or from fertilizing the secondary oocyte. So this ensures that only one spermatozoa can penetrate through the zona pellucida to fertilize the secondary oocyte. So once the fastest sperm penetrates the zona pellucida, is okay. Zona pellucida 2 or the fertilized egg produces the ovostacin, which ensures that secondary the zona pellucida 2 is degraded so that multiple or polyspermia cannot occur. All right, so we deal with the first phase, which has to do with penetration of the coronal radiator. The second phase of fertilization, deals with penetration of the zona pellucida. Of course, I've already said that the zona pellucida is a glycoprotein shell. Facilitates and maintains sperm binding, and then uses what acrosomal reaction. Okay. Zona pellucida 3 facilitates both the binding and then acrosomal reaction. Okay, it releases acrosin, which is an acrosomal enzyme that allows the sperm to penetrate the zona pellucida. Okay, so that they can come into contact with what the plasma membrane of the oocyte. All right, so penetration of the zona pellucida. Permeability of the zona pellucida changes once the first sperm comes into contact, or once the fastest sperm comes into contact with the zona pellucida. So please follow the cursor. Okay, so once the zona pellucida is okay, no other sperm can penetrate the zona pellucida. Is okay. So you are saying that the permeability of the zona pellucida, it changes when the head of the first sperm or when the head of the fastest sperm, which reaches the zona pellucida first, comes into contact with what? The zona pellucida. Okay, so when it comes into contact with the zona pellucida, okay, it causes the release of what? Lysosomal enzymes from the cortical granules. So these are the cortical granules. Okay, they contain enzymes, lysozymes. Okay. Now this cortical granules, okay, ensures that the zona pellucida cannot be penetrated by any other sperm when the cortical granules pellucida, okay, to prevent multiple sperms from entering or fertilizing the secondary oocyte. Okay, and then this, okay, or this is known as polyspermia. Okay, they prevent polyspermia, multiple sperms from fertilizing the secondary oocyte. Please, any questions?
I'm sorry.
All right, so
Hello.
these are the cortical granules.
I'm saying, has there ever been any
Someone asking a
case
question.
where I know the error margin is like very small.
Come again.
Yes, please. So the error margin is very small. Has there ever been a case where primary the error margin is has there ever been a case where to
I can't really hear you well. So here we are. These are the cortical granules. Okay. So the cortical granules ensure that once the first sperm penetrates through the zona pellucida, they release these granules, which kind of closes the zona pellucida. Okay, they coat the zona pellucida, preventing multiple sperms from entering. So I've already explained what the zona pellucida is. I said that it consists of what? Glycoprotein. Is okay, covering the primary oocyte. So these are the zona pellucida. Is okay. So once the first sperm enters, okay, it releases the cortical granules, releases their granules, preventing or closing or yes, closing the zona pellucida, preventing multiple sperms from entry. All right, so the last phase of fertilization is the fusion of the what? Of the oocyte and then the sperm cell membrane. Okay, so we are saying that of course is the oocyte and then that is the sperm membrane. Okay, so they come into contact with each other and then fuse it together. Okay, so the initial adhesion of the sperm to the oocyte. So of course the sperm has to come into contact with the oocyte. Okay, now this initial contact is initiated by what? Or is mediated by interactions of integrins on the oocyte and then their corresponding parts on the spermatozoa. Okay, so we are saying that fusion of the spermatozoa membrane and then the secondary oocyte occurs due to the presence of fertilin. Okay, now this fertilin is located on or on the spermatozoa CD9 liquid. Okay, on the oocyte plasma membrane. Okay, so the initial contact between the oocyte and then the spermatozoa is as a result of this fertilin, okay, which consists of an a spermatozoa integral protein present on the sperm and then CD9 molecules present on the oocyte. All right, so you should note that the head and then the tail of the sperm enter. So you can see that the head and then the tail enters the what? The cytoplasm of the oocyte. Okay. But the plasma membrane of the spermatozoa is left behind on the what? The surface of the oocyte. All right, so let's happen. So now the sperm has enters the secondary oocyte to fertilize the oocyte. What happens after that? So we are saying that the oocyte respond in three ways as soon as the spermatozoa enters it. So first of all, there is the cortical and then the zonal reaction, which I said that the cortical granules will release their granules, preventing polycythemia. Okay, and then the oocyte resumes the second meiotic division, and then there is also metabolic activity of the oocyte. Okay. So already I've explained the cortical and then the zonal reaction. So the cortical reaction, okay, there is the release of lysosomal enzymes from the cortical granules. Normally, these are the cortical granules. And then the oocyte membrane becomes impenetrable. So no other spermatozoa can penetrate the oocyte. Okay. And then, of course, the zona pellucida enters its structure, alters its structure and composition to prevent sperm binding and penetrating. Okay, so that is the cortical and then the zonal reaction. So for the cortical and then the zonal reaction, okay, there is a release of enzymes. Okay, there is a release of enzymes from the cortical granules, okay, making the oocyte impenetrable to other spermatozoa. Okay. Okay, so that is the cortical and then the zonal reaction. So you can see this cortical granules. Okay, they release their granules, preventing other sperms from penetrating the zonal pellicida. Any questions? Any questions? All right, so on post-fertilization, as you said, three things happen. It's okay. So the first one has to do with the cortical, then the zonal reaction. The second one is the resumption of the second meiotic division. And then the third process has to be metabolic activity of the oocyte. So we are done with the cortical and then the zonal reaction. Let's look at the resumption of the second meiotic division. All right, so for the resumption of the second meiotic division, we are seeing that the oocyte completes its second meiotic division once the sperm enters the oocyte. Is okay. Now, once the sperm enters the oocyte, okay, the structure is now known as what? Or the oocyte is now known as what? Ovum. Is okay? Any questions? Hello?
No, sir.
Hello.
Are you following? Yeah. Are you following?
Yes,
Yes,
sir.
sir.
We are listening.
All right, so give me a second. All right, so we are saying that once the sperm, it's no longer known as what oocyte, but known as what ovum. Okay. Now, one of the daughter cells known as what is known as polar bodies, we see very little cytoplasm. And then the other daughter cell known as what the definitive oocyte has 22 chromosomes plus X. Okay. And then these chromosomes are arranged on the vesicular nucleus to form the female nucleus. Is that okay? All right, so here we are. That is the female pronucleus, and then that is the spermatozoa. Is that okay? So we are saying that this is the what? The female pronucleus, and then that is the polar body. All right, so for the metabolic activity of the oocyte, what we need to understand is that the nucleus of the sperm, okay, becomes swollen. Okay, so of course, you know that the sperm has a spindle shape. Once it penetrates the oocyte, okay, the nucleus becomes, swollen. And when it swells, it forms what is known as a male pronucleus. So that is the male pronucleus, and then that is the female pronucleus. Okay, so the male pronucleus lies close to the female pronucleus. Okay, so the male pronucleus lies beside the female pronucleus. Now, the cells of the sperm detaches and then degenerate. So if you look at it carefully from here, you can see that the male pronucleus lacks the cells of the sperm. Of course, we only need the nucleus because the nucleus is what contains the genetic material. Okay. Right now, the sperm is not going to move again, so we don't need a cell, which was needed for what? Movement of the spermatozoa all the way from the seminiferous tubules. okay, all the way from the seminiferous tubule to the ampulla of the uterine tube. No worry, we break shortly.
Sir, please, how does the nucleus get swollen?
How does the nucleus get
Swollen.
oh, get swollen? It's a result of metabolic activity. Okay, so the nucleus of the cell becomes swollen, forming the male pronucleus, and then lies close to the female pronucleus. Okay. Then you are saying that the tail, of course, now at this stage, you don't need the tail. Okay. Because the male pronucleus and then the female pronucleus are going to mix. Their nuclear material are going to mix. And then we don't need the tail of the sperm. Okay. So the tail of the sperm detaches and then degenerates. Okay. And you are saying that the male and then the female pronuclei come close to each other. And then lose their nuclear envelope, okay, and then their chromosomes begin to intermingle, okay, to form the diploid cell. Okay, so once their nuclei material, that is the chromosomes, mix or they intermingle, they form a single cell, okay, known as what? The zygote. Is that okay? So once
Yes, sir.
they intermingle, they form a single cell known as what? The zygote. Any questions so far? Any questions so far? Any questions so far?
No, sir.
Are you sure? All right, if no question, let's progress. All right, so after the fusion of the male and then the female pronuclei, what happens is that the centrosome contributed by the spermatozoa form mitotic spindle apparatus. Okay, the zygote then undergoes its first meiotic division, and that first meiotic division kind of splits the cell or the zygote into two cells. Okay, now the two newly formed daughter cells, each of them is known as what? A blastomere. Okay, collectively the two blastomere form the what? The embryo. So I hope you can differentiate between the ovum. No, first of all, you can differentiate between the oocyte, the ovum, the zygote, and then the embryo. Hello. Hello.
Hi.
How you can differentiate between all?
You said
I hope you can differentiate what the secondary oocyte is, what the ovum is, what the zygote is, and then what the embryo is.
yes, sir.
What I'm saying that once the male and then the female pronuclei fuses, okay, they form a single cell, and that single cell is known as what? A zygote, right? Now the zygote then divides into two cells. Okay, it undergoes the first meiotic division, okay, to split into two cells. That two cells, each of the cells is known as what? A blastomere. Now, the two cells together are known as what? the embryo. So the embryo comes when the zygote, which is formed as a result of fusion of the male and female nuclei, undergoes its first meiotic division. Sorry, mitotic division. Okay. Now, what you need to know is that all the centrosomes of the new individual are derived from the father, and then all the mitochondria are derived from the mother. Is okay. So let's look at the results of fertilization. Okay. So after fertilization, one, there is what restoration of the diploid number of chromosomes. Di means what? 2. Okay, remember the sperm was what? Haploid. The secondary oocyte was also what? Haploid. So once they mix, they become what? Or they form a diploid cell. That means that there is restoration of the diploid number of chromosomes. Okay, so in that process, that means that half of the chromosomes was from the father, and then the other half was from where? The mother. Okay, so in that process, the zygote contains a new combination of chromosomes, different from the parent. And then you can also have determination of the sex of the individual. Of course, we know that the female carries an X chromosome, the sex chromosomes or the gamete. The female carries X, and then the male carries, or the female has XX, and the male has what? XY. So if the male releases an X, now we lead to the formation of what? XX, which is a female. And if the male releases a Y, we know that XY is what? A male. Okay, so we are saying that at the end of fertilization, the chromosome sex or chromosomal sex of the embryo is determined. So whether you are female, which is XX, or whether you are male, which is XY, will be determined right after fertilization. Okay. Then the last, process or the last result of fertilization is the initiation of cleavage. Remember earlier I said that when the zygote is formed, it's split into two cells. Each cell is known as what? A blastomere. Okay, and that process where the zygote splits into two cells, okay, is known as what? Cleavage, or it begins or it initiates the process of what? Cleavage. Cleavage means what? To divide. So fertilization results in initiation of what? Cleavage. Is that okay? So without fertilization, the oocyte usually degenerates 24 hours afterwards ovulation. All right, please, any questions? Any questions? Let me see if some of you have questions.
Hi, say. Hi.
Any questions so far? Any questions? If no question, then we are done with fertilization. We'll wait for about 10 minutes and then start with cleavage, or the first week of embryonic development.
Sir, please let us listen to Sir. What time will you close, Sir?
Let's wait for 30 minutes. No, 20 minutes, sorry. So we'll come back at. Hello.
Hi.
Yeah, so please let's wait for 30 minutes. Okay, and then come and start the next lecture, which will start at 4:30. Okay.
Sir, what about 4:40 or
4:30.
So when
We
is
are
the
breaking
class
for
ending?
20 minutes.
that we
When
beg?
When is the class ending?
I know you are very. So the class will end at 6. So we are breaking for 20 minutes.
6 o'clock.
We'll resume at
The class went at 6 o'clock.
The Wi-Fi, the Wi-Fi, the Wi-Fi.
He said, "Me, I'm using
The
data.
Wi-Fi is not strong.
Me, I'm using data." Please.
All right, so
No
please, we are
data,
waiting
no
for.
data.
Please, my data.
All right, so
Then
let's
we have to charge our
break
laptop.
for 20 minutes. We'll come back.
Please hit the subscribe and like button already if you are enjoying this.